We want to work on simplifying square roots. Not every number is, a perfect square. So we have some rules that can help us, and one of the rules is called the product rule. It says if you have the square root of a times b, so two, values being multiplied, you could split it up and make it the square root of a times the square root of b. You could split up those factors. It works the other way too. So we'll see examples of both, but first we'll use this one. So we're going to simplify this radical expression. And right now it says the square root of 300. Now 300 is not a perfect square, but 100 is a perfect square. So I could think of this 300 as 3 times 100. Now I could split it up and make it the square root of 3 times the square root of 100. But I know the square root of 100, that's 10. Now the only thing is, when we simplify radicals, we put the 10 in front of the radical part, or in front of the square root. So you'd write it as 10 times the square root of 3, and that would be considered simplified. How do you know it's simplified? Well, you can't break 3 down anymore, and there's no square root of 3. Okay. Now the next one might be a little more complicated. We've got 162. Now, I know 162 wasn't on my list of perfect squares, but, I don't know what it is. I do know, I start with what I know, though. I know 2 goes into 162. So I'm going to split this up into 2 times 81, right? Okay. Now, 81, that looks familiar to me. I know the square root of 81. But what about the a to the 5th and the b to the 4th? Well, you can think of that a to the 5th as A. This is one way to do it. And think of the b to the 4th as B. And then for every pair, think of 81 as 9 times 9. This is just another approach. That's that's 2, 9 times 9, that's 9 squared. So the 9 gets to come out. And then think about, well, those two A's, they'll make an A on the outside. There's another pair of A's, so that's going to be times A. But see, this A doesn't have a partner. And then there's a B that's going to come out, and then there's another B that's going to come out. Now, what's left inside the radical? You've got a 2, and you've got an A, 2A. Now, we would write that as 9A squared b squared radical or square root 2a. And it looked like that. Kind of a long one. So the first one was a little bit easier to do, but this one had a little more going on. And you can write those out, no problem. Or if you wanted to think of a to the 5th, as a squared times a times a. Another way you can think about it is, how many times does 2 go into 5? Because it's a square root, it goes 2 times, right? And then there's 1 left over. So you're getting an a squared on the outside, and then there's the, whoops, darn screen. There's the 1 that's left over. Okay, so a few different ways to look at it, but hopefully it makes some sense.